So this is the 31st session on rigid body kinematics. In this video also I'll take up a problems related to pure rolling problems and calculation of radius of curvature. Okay. So I'll discuss the problem. So I'll write down the problem first. Okay. So again, one more thing I have to say that if you go through it completely, if you understand this fully, then it's sufficient. You don't have to go anywhere else. Okay. You don't have to take up any costly institute. Okay. This will be sufficient. And if you just take up the problem from any other source, I'm sure you'll be able to solve most of them. There's no doubt about it. Fine. All right. So I'll write down the question first. Okay. Circular drum with center at C and radius r equal to 2 beta is initially at rest, and it it's and it begins to move over a fixed the surface, and over which it undergoes pure rolling. With constant clockwise angular acceleration of beta equal to 4 radian per second square. Okay. At t बराबर 4 second after the start of motion, three points P1, P2 and P3 of the drum are as shown. Find the tangential acceleration and radius of curvature of path of these 3 points. Okay, fine. So this is the question. All right. Okay. Now this I'll wrap this. Okay. So first what I do, I draw the diagram of the situation. Fine. So this is the drum at time 0. Initially rest, it was at rest. This is the fixed horizontal surface. This is the center C of the drum. This is the radius R. R is given to be 2 meters. Initially it is at rest. Now it begins to rotate clockwise at constant angular acceleration beta equal to 4 radian per second square. 4 radian per second square. Okay, and here it undergoes pure rolling over the fixed horizontal surface. Now what will happen? Tell initially beta is clockwise 4 radian per second square. So from pure rolling, acceleration of center should be towards rightward. Okay. Now this is the situation at time 0. At t bra 4 second. This is the situation at t bra 4 second. Okay. This is the situation at t bra what? 4 second. At t bra 4 second, the center has acquired some speed v. Since acceleration is rightward, initially it was at rest center. So 4 second at a center moving towards right at a speed v. It has also gained some clockwise angular speed omega. Omega should be clockwise because here it is undergoing pure rolling. And center acceleration of center is again a, because I'll explain it just now. And the angular acceleration of the cylinder is beta. This is a beta constant 4 radian per second square. Okay. So at 4 second, this is the highest point of material point of the drum is P1. This is the point on the circumference of the drum at same horizontal level at center C, P2. And P3 is somewhere here. CP3 makes an angle of 60 degree. CP3 makes an angle of 60 degree with the vertical. Okay. So now we have to find the tangential acceleration of these 3 points and also the radius. Okay. I'm just okay. Video. So now what I was telling, you have to find the tangential acceleration of these 3 points and also the radius of curvature of path of these 3 points at the given instant. Okay, fine. So now, question is, how do we proceed? You have to find the tangential acceleration and radius of curvature. Okay, fine. So what I'll do, I will calculate the radius of curvature and tangential acceleration of P1 first, then P2, then P3. Okay. First I'll calculate the radius of curvature and tangential acceleration of point P1. Then I'll calculate it for point P2. And then I'll calculate it for point P3. Alright, fine. So, now first what you have to do, see, basic idea will be that what we'll do, we will apply the, we will find the, for example, suppose we have to find the tangential acceleration of point P1, okay, and radius of curvature of point P1. In order to determine the radius of curvature of point P1, what we'll do, we'll write down the normal acceleration of P1 in 2 different ways, okay, and then equate them. I'll just demonstrate it here, okay, fine. So, first I'll do it for P1. For point P1, okay, fine. So, I draw the diagram here for the sake of clarity. This is the point P1, okay, the center C, this radius R, okay, fine. See, What we'll do, we apply the SRC procedure for acceleration between C and P1. Okay. So center C is moving at a speed V at t bravo 4 seconds. It is rotating at a constant angular, so it is rotating at angular speed omega clockwise, and P1 is the highest point. Okay, this is the radius r. So what we do first, we find the total acceleration of P1. Okay, so SRC for acceleration between C and P1 in ground frame. Okay, so SP arrow C, OP any other point arrow P1. Now I draw the line joining SP and OP, which is just this line CP1. Okay, I give the acceleration of selected point C to other upper point P1. Acceleration of center C is A rightward, so I give A rightward to P1. Now we must know the value of A. Now here the drum is undergoing pure rolling over a fixed horizontal surface. So from pure rolling criteria for acceleration, we know that A is equal to R beta. R is given to be 2 meter and beta is given to be 4 radian per second square. So acceleration of center of the drum with respect to ground is 8 meter per second square in rightward direction. So this I give 8 meter per second square I give to what? P1. Now I write down the sentence. P1 moves in a angular acceleration and omega and beta of the drum both are clockwise. So point P1 moves in a clockwise circle with center C and radius R. The two accelerations have to be given to P1. R beta in rightward direction. R beta is simply 8. So I give 8 meter per second square. Okay. And omega square R to P1 towards the selected point C. Omega square R. Now you must know the value of omega. Now beta is constant. So omega equal to omega naught plus beta t. Omega is equal to omega naught plus beta t. Omega naught is the initial angular velocity of drum, 0. And beta is how much? Beta is given to be 4. Beta is given to be 4. And t is given to be 2 seconds. So omega is equal to 8 radian per second at this instant. Okay, fine. Beta t. T is 4 seconds, sorry. This is 4. And beta is also radius 2 meter, beta is 4. Okay, so this is 16, sorry. This is 16 radian per second. Omega square becomes 256. R is 2 meter. 256, omega square 256 into 2, 512 meter per second square. Suppose I set up the coordinate system in this way, x rightward, y downward. Okay, so what is the acceleration of point P1? Tell me. Acceleration of point P1 with respect to ground is 8i plus 8i, 16i. Vector sum these three terms, 8 and 8 along x axis, so 16i hat plus 512 j hat. This is the acceleration of point P1 with respect to ground. Okay, fine. So I hope this is clear. Fine. Now what I do, see, I love this portion. Okay. Now see, now what I do, I apply is I find the speed of point P1. Okay. SRC, for that we apply SRC for velocity between C and P1. SRC for velocity between what? C and P1. So SP arrow C, OP arrow P1. Now I draw the line joining SP and OP, that is C and P1, which is the vertical line. Okay, this is C, this is P1. I give the speed of selected point C to other point P. I give V. Now V is what? Pure rolling condition. Here it undergoes pure rolling over a fixed surface. So V is just equal to R omega. R is 2. Omega is beta t, as I have determined here. See, beta t. Beta is 4, t is also 4. Okay. So 4 into 4. That is 32 meter per second. Now I write down the sentence. Omega is clockwise. P1 moves in a clockwise circle with center C, radius R. I give a speed omega R to P1 in rightward direction. Then it will be clockwise. R omega. R is 2 meter. And omega is how much? Omega is 16. So 2 into 16 becomes what? 32 meter per second. Okay. So by third step we apply combination. The velocity of P1 with respect to ground becomes 32 plus 32, 64 meter per second in rightward direction. Okay, fine. Alright. So this I rub it here, okay. So now, suppose radius of curvature of the curve of point P1 is how much? Rho 1. So, now one thing, if I draw the approximate shape of trajectory of P1, see this is the drum at time 0, okay? This is the drum at time 0, this is point P1. If I draw the approximate shape of trajectory of point P1, it is something like this. This is the approximate shape of trajectory of point P1. Okay, fine. Suppose at t barabar 4 second. Okay, fine. P1 again comes here. So its velocity in this direction is how much? 2v, 64 meter per second. 64 meter per second is the speed of P1 in rightward direction. Alright. So this is the unit vector along tangent to its velocity. And this is the unit vector along En hat, which is simply j hat in this problem. And this is just Et hat is I hat. Okay. So we can write acceleration of P1 with respect to ground is equal to its component along tangential direction, that is the tangential acceleration, at1, plus its component along northward along En hat, et1 hat, En hat. Now at1 is the tangential acceleration of P1 which we have to determine. at1, et1 hat, and an1 is the normal acceleration of P1 which is in this direction. This becomes how much? Speed of this point P1, Vp1g square by rho 1 into En1 hat. Okay, this is AP1g. Alright. So this term and this term, they are equal. They are identical. They are both identical. So these are a bit here. Okay, fine. So I equate these two. This and this I equate. So what do we get? 16 I hat plus 52 512 j hat. That is same as this. Et1 hat is just equal to what? I hat, and En1 hat is what? J hat. So this becomes et1 hat, En1 hat. Now equate the corresponding coefficients. This is just I hat and this is just j hat. So I equate the corresponding coefficients of I and j on both sides. So at1 becomes 16 meter per second square. This is the tangential acceleration of point P1. This are a bit okay, fine. And I equate the j component. This is just n1 hat is j hat. This is also j hat. So n1 is equal to 512 meter per second square. This will be written as Vp1g whole square by rho 1, 512. Now Vp1g is how much? 64 meter per second. So I get here 64 into 64 by rho 1 is equal to 512. Okay. So rho 1 becomes, this becomes 68 times 64 by, this becomes 8 meter. This is also one answer to the problem. Okay, Fine. So radius of curvature of the curve at point P1 is 8 meter, and tangential acceleration of point P1 is 16 meter per second square. Fine. All right. Clear. R into beta. Beta was how much? Beta is 4. R into 2. Beta R. R beta. 2 into 4. 8. 8. 16. Oh yeah, 16 is correct. All right. Fine. So this is the value of rho 1. All right. Now I repeat the problem for P2. For the case of P2, I repeat. Okay. This I'll rub it. Going. Now I repeat it for the case of for P2. Okay. Again I draw the diagram here, rough diagram. Okay. This is time 0. This is center C. This is radius R. Here the body is at rest. It begins to rotate at beta. At t equal to 4 seconds. The drum is here. At this point, center C is moving rightward at speed v. It is rotating at omega. Beta is as such. A acceleration. This P2 is the point on the circumference of the drum at same vertical level, same horizontal level as center C. Now for P2 again we have to determine what? We have to determine its tangential acceleration and radius of curvature of the curve at P2. This we have to determine. Okay. So what I do first, we'll again apply SRC between C and P2 and find the acceleration of P2 in Aegean rotation. This is x and y axis coordinate system is as shown here. Alright, fine. So SRC for acceleration between C and P2 in G frame. G meaning ground frame. Okay, fine. In G frame. So again, first of all, SP arrow C, OP arrow P2. Then I draw the line joining C, SP and OP, that is line CP2, which is horizontal. Now I give the acceleration of selected point C to point P2, which is A. A, as I have determined previously, it is just R beta. R is how much? R is 2, beta is 4. Beta is 4 given, R is 2. This moves 8 meter per second square. Now I write down the sentence. P2 moves in a clockwise circle with center at C and radius R 2 meter. So I give two accelerations to P2. Omega square R to P2 towards C. Omega is how much? Omega is beta t. Beta is 4. T is also 4. So 16. Omega square R becomes 16 square into 2. This becomes 512 meter per second square. And one more I give R beta to P2. Downward direction. R is how much? 2. Beta is how much? 4. 4 into 2 what? 8 meter per second square. So acceleration of P2 is the vector sum of these three terms. So P2G will be 512 8 I hat plus 512 minus I hat plus 8 J hat. This becomes minus 504 I hat plus 8 J hat meter per second square. Alright, fine. So this I'll rub it here, okay? Now what I do, I again draw the approximate shape of trajectory of P2. So see, this is the drum at time 0. This is the horizontal surface. This is the point P2 at some instant. Okay. If I draw the approximate shape of trajectory of P2, it's something like this. Approximate shape of trajectory of point P2 is this one. Okay. Now what I do? This is again x-axis, this is y-axis. Alright, fine. Now I determine the speed of P2, Vp2g. This we know is tangential to the path at P2. This is well known. Its direction is tangential to the path at point P2. So this is ET hat, ET2 hat. And inward normal is this one, EN2 hat. Alright. First what I'll do, I'll write AP2G in another way. AP2G I'll write down in another way. How? That has a component along tangent AT2 E2 hat plus this is the tangential acceleration of P2, this is the normal acceleration of P2. Okay. So this term and this term, they are identical, they have to be equated. Now what do we do next? Tell me, what should I do next? You must also know A and 2. So how to write A and 2? That becomes Vp2g square by rho 2. Now Vp2g is the speed of P2. To determine A and 2, you must know Vp2g. Now how to determine Vp2g? We apply SRC procedure for velocity between C and P2. So SRC procedure for velocity between C and P2 in G frame, that is ground frame. Okay. So SP arrow C, OP arrow P2. Okay. I draw the line joining SP and OP, that is C and P2. Then I give the speed of selected point C to speed P2. Speed of C is V rightward, so I give V rightward. V is equal to R omega. R is 2. Omega is how much? Beta T. 4 into 4, 16 into R2, 32 meter per second. Now I give say the sentence. P2 moves in a clockwise circle with center at C and radius R 2 meter. So I give omega R to P2 in downward direction, right angle. Omega is how much? 4 into 4. Beta T. 4 into 4. And R is 2. So 32 meter per second. Alright. So Vp2g is the vectors of these two terms. This will be 32 root 2 along the bisector because they have the equal magnitude. Okay, fine. Now these are a bit okay, fine. So resultant velocity of Vp2 is the vectors of these two. That will make 32 root 2. That will be along the bisector of these two because they are equal. Diagram of vector addition rule. Okay. So I draw the diagram here at t value of 2 seconds. T value of 4 seconds. Okay. So this is P2 here. Okay. Fine. P2 is it's moving at a speed of 32 root 2 meter per second at an angle of how much? This 45 degree. Okay, fine. So now this is along tangent. This is ET2. This is along EN2. This is 90 degree. This is 45. This also is 45 degree. Alright, fine. So this two and this two are equal. So what I do, I equate the x component of AP2G in both directions. X component. The x component of Vp2G will be sum of x components of these two. X component this will be 32 root 2 into cos 45 degree 1 by root 2 minus En2. En2. How much is En2? En2, sorry, En2. This is En2. Along this direction expression is AT2. Along this it is En2. So 32 root 2 cos 45 minus AN2 cos 45 degree. That is just equal to how much? Just this are the bit here, okay? So this is 32 root 2. So normal expression of this will be an2 1 an2 cos 45 degree minus at2 cos 45 degree minus an2 cos 45 degree. That is same as the x component minus 504, and I equate along y direction. At2 sin 45 degree, that is 1 by root 2 plus an2 by root 2, that is just equal to 8j. Okay, fine. Now I love this one, okay? So now what I do, I add both of them, okay? If I add them, this 2 goes away. The add if it becomes 282 root 2, this term goes away. Barabar minus 496. So 82 becomes minus 496 by root 2. This becomes minus 248 root 2 meter per second square. Minus indicates that the speed of at that instant speed of P2 is decreasing with time. Okay, fine. Now this side a bit, okay? Now I subtract them. This one is this, I get the normal component. This one is this term goes over. This one is this, becomes how much? And 2 by root 2 plus and 2 by root 2 becomes 8 minus 504. That becomes 8 minus 504. So this becomes how much? And 2 root 2 equal to 512. Now and 2 is how much? Vp2g square. This is equal to Vp2g square by rho 2 into equal to 512. Okay, fine. This are of this one, okay. Now Vp2g is how much? 32 root 2. So Vp2g square becomes how much? 32 root 2 whole square into root 2 by rho 2 is equal to 512. So root 2 becomes 32 into 32 into 2 into root 2 by 512. Okay. Now this will simplify. How much will it be? 32 into this becomes 256, 8, 4. This becomes 4 root 2 meter. This is the required answer. Okay. The required answer is how much? 4 root 2 meter is therefore the required answer. Okay. Fine. So rho 2 becomes how much? 4 root 2 meter is the value of rho 2. So rho 2 becomes, I'll just check the calculation, 256, 8, 4 root 2 meter. Yes, correct. Alright, fine. So 82 also I found out, and A and rho 2 also I found out. Okay. Now what you have to do? You have to repeat the entire thing for P3. For P3 you have to repeat now, P3. Achha, one more thing I would like to say here. While solving the finding AT2 and rho 2, I did not express ET2 and EN2 in IJ form. I could have done it that way also, as I did in first part for P1 I did. I could have expressed ET2 and EN2 in IJ form and then equate both of them. That was also a possible way. But I used it directly from the diagram. I used that angle itself, 45 degree. Okay, fine. So this are a bit now. Now I repeat the problem for the case of P3. I draw the diagram again. This is a diagram at t barabar 4 seconds. Okay, fine. Coordinate system is as usual again, as I have been showing it. This is center C. This is radius R, 2 meter. This is the vertical line. This is P3. This is equal to 60 degree. Again, now we have to find 83 and rho 3. Okay, fine. So now what do I do next? Again, first I do center is moving at acceleration A rightward, R beta. R is 2, beta is 4. 8 meter per second square. Omega is also beta t, 4 into 4. 16 radian per second square is omega. Alright, fine. 16 radian per second square omega per second, sorry. Now what I do? Beta is again 4 radian per second square clockwise. I apply SRC procedure of acceleration between C and P3. SRC procedure between C and P3 in G frame. G with the meaning ground frame, okay? So first I write the formality. SP arrow C, OP arrow what? P3. I draw the line joining SP and OP. That is the line CP itself. C is here, P is here. This angle is 60 degree. Now I give the acceleration of selected point C to P3, which is simply A rightward. A is how much? R beta from pure Lorentz criteria, as I have been determined. R is 2, beta is 4. 8 meter per second square. Now I write down the sentence. Omega is clockwise, beta is clockwise, omega is also clockwise. P3 moves in a clockwise circle with center at C and radius R. So I give two accelerations to P3, omega square R. Omega is how much? Beta t, 4 into 4, 16. Omega square becomes how much? 256. R becomes 2. This becomes 512 meter per second square. And I give R beta to P3 in this direction. At right angles to this direction. R is 2, beta is 4. 8 meter per second square. By geometry, this angle will also be 60 degree. Okay. So AP3G is the vector sum of these three terms, this and this. Alright, fine. So what do we do? AP3G is the vector sum of this one. This is on x-axis, 8i. This becomes 8 cos 60 degree I hat. A by 2 I hat plus 8 sin 60 degree j hat. 8 root 3 by 2 j hat. And this one, omega square, 512. This also has a component along x-axis. It is simply sin 60. Root 3 by 2, that is along negative x-axis. And 512. 512 cos and sin. Okay, cos 60 degree. 1 by 2 into j hat. Okay. So this becomes how much? 8 and 8 by 2. 8 by 2. 8 by 2 is 4. 4 plus 8, 12. 12 minus 256 root 3 into what? I hat. Okay. Plus j hat. J hat is where? Here and here. Only two j hats are there. So this is 256 plus 256 plus 8 root 3 into what? J hat. Okay. This is AP3G. So AP3G how much? This becomes how much? Tell me. This becomes 4 plus 8, 12 I hat minus 256 root 3 I hat plus 4 root 3. This I'll check. This 256 plus, this is 4 root 3, sorry. 256 plus 4 root 3 j hat. Okay, fine. Alright. I hat becomes 8 plus 4, 12. 12 minus 256 root 3. And 256 plus 4 root 3 j hat. Okay. Now what I have to see? Again, I draw the approximate shape of trajectory of point P3. I draw the approximate shape of trajectory of which point? P3. Approximate shape of trajectory of P3 will be something like this. Okay. So here ET3 is velocity is along tangent to the path along unit vector ET3. En normal acceleration is along unit vector En3 hat. These are both right angle. Okay. Fine. Alright. Now What do we do now? What to do next? That is the question. Okay, fine. See, one thing I'd like to say. One thing I'd like to say here, that how to find VP3G, because if AP3G is equal to AT3 ET3 hat plus AN3 EN3 hat. Okay, fine. This error, this one. Okay, fine. So for now, what is AN3? Normal acceleration of P3. So AN3 becomes VP3G square by rho 3. Now rho 3 determination for, you need this VP3G. So you apply SRC procedure for velocity between C and P3. So SRC procedure for velocity between C and P3 in G frame. I draw the line joining C and P3 first. Oh, sorry, SP arrow C, OP arrow P3. Okay, I draw the line joining SP and OP. So this is the line joining SP. SP is C, OP is P3. This angle is 60 degree. I give the speed of selected point C to P3. Velocity of C will be how much? Velocity of C is how much? V, R omega. Omega is 8, R is 2. R omega becomes what? 32 meter per second. Now P3 moves in a clockwise circle with center at C and radius R, 2 meter. So I give R omega. R is again 2. Omega is again 8. 16. So 16 to 2 becomes how much? 32 meter per second. This angle by geometry is 60 degree. VP3G is the vector sum of these two. Vector sum of these two will be how much? Vector sum of these two will be how much? Tell me. It will be from parallelogram law of vector addition. It will be found. And this will bisect the angle between these two. So this will be 30 degree. This will also be 30 degree. Now VP3G will be how much? From parallelogram law of vector addition, it will be how much? 32 square plus 2 into 32 into 32 into cos 60 degree, that is simply half. Half goes away, 32 becomes common. 32 root 3 meter per second. This becomes VP3G at an angle of 30 degree. Okay, fine. Now we know that tangential acceleration, its line of action of tangential acceleration is along VP3G. So see, in this diagram, if I show, this is along AT3 is along this direction. Okay, and this makes an angle of how much? 30 degree. And AN3 is along this direction. Right angle to this 30 degree, 90 degree. This becomes how much? By geometry 60 degree. Okay, fine. Now what I do, I write down the, you can see this. Now what to be done next? That is a question. What to be done next is a question. Fine. All right. See, AP3G becomes AT3 hat plus AN3 EN3 hat. This is AP3G. All right. Fine. So it will be better if what we do. Again, I write down this term I equate these two. Okay. Fine. So here again, instead of by geometry, I write down ET3 and EN3 in IJ form and equate it to this term. Then problem will be solved. Okay. So this becomes AT3. What about ET3 hat? Unit vector along this direction. So this is how much? Cos 30 degree I plus sin 30 degree J plus EN3 is how much? Cos 60 degree minus I plus sin 60 degree plus J. Sin 60 degree plus J. So this is the acceleration of AP3G. Okay, fine. Now what I do, this I rub. Okay, fine. So this is simplify. This becomes how much? AP3G becomes, here I, here also I. So 83 root 3 by 2 minus 83 by and 3 by 2 into I hat, and J hat is how much? Plus 83 by 2 plus an3 root 3 by 2 into what? an3 root 3 by 2 into J hat. So this is the same as this, as we found here. 12 minus 256 root 3 I hat plus 256 plus 4 root 3 into J hat. Now equate the corresponding I and J coefficients on both sides of this equation. So if you equate the I component on both sides, what do we get? 83 root 3 by 2 an 3 by 2 12 minus 256 root 3, and if you equate the an3 component, minus I hat and J hat. Okay, fine. Okay. 83 minus an3 by 2. Okay. And 83 by 2 plus an3 root 3 by 2. That becomes 256 plus 4 root 3. Now if you solve these two equations, we get 83. Okay. So I'll let we have to solve both of them. There's no way out. Okay. So what I do, I'll net one of them. Okay. So from this equation we see that 83 is how much? 83 is equal to 512 plus 8 root 3. 512 plus 8 root 3 minus and 3 root 3. Now this 83 is substitute in this equation. Root this into 83. 512 minus and 3 root 3 minus and 3 by 2. 12 minus 256 root 3. Okay, fine. So from this we get an3. This you can see. Now I love this one, fine. So this becomes how much? Now I simplify this problem. This is how much, tell me. So the an3 I shift that side. an3 here and 2 an3 goes that side. an3 by 2 plus 3 an3 by 2 root 3 3 plus 3 an3 by 2. Okay, fine. That becomes how much? 512 root 3 by 2. 512 root 3 by 2. an3 by 2 plus 3 an3 by 2. 512 into root 3 by 2 plus 8 into 3, 24 by 2, 12 plus 256 root 3. Okay. So this becomes 2an3. This becomes how much? 256 root 3 plus 512 root 3 plus 12. Okay. So this implies an3 is how much? 256 root 3 plus 6. This is an3. Now an3 is what? Vp3g square. Vp3g square by rho 3. That becomes how much? 256 root 3 plus 6. Now Vp3g square is how much? 32 square into 3, as we determined just now. 3 into 32 square. This I determined. Yeah, you must see the SRC procedure. So this becomes 32 square into 3 by rho 3. 256 root 3 plus 6. Okay, so we have obtained how much? We have obtained rho 3 also. Rho 3 also I have obtained. Fine. This are a bit here. Fine. So I solve this again here. If I solve this problem here, how much rho 3 becomes? 32 square becomes 1024 into 3, 3096 upon 256 root 3 plus 6 meter. This is the required answer to rho 3. Okay. So A and 3 we have determined. Now substitute the value of A and 3 in this equation, then I get 83. Now wrap this one. Fine. This is substitute A and 3 here. So how much is 83? There's one answer here, see. One answer. 83 is 512 plus 8 root 3 minus root 3 into A and 3. And how much is A and 3? 256 root 3 plus 6. This is A and 3. So this becomes how much? 512 minus 256 into 3 minus 6 root 3. So this becomes how much? Minus 256 plus 2 root 3 meter per second square. This is therefore the required answer. This is overall it is negative, which means that speed of VP3 at that instant is decreasing with time. Okay, so this is the required answer. See, this was the 31st video on rigid body kinematics. I took up this problem which is highly conceptual, important question. If you understand this fully, it will be of great help. Okay, radius or curvature problems are frequently asked. If they are not asked, they can be asked in the coming papers. So this you keep into mind. Okay, so I'll solve this fully. Okay, the 31st session I fully solved it. All right, here. Now in next session also I take up another concept that is not strictly in rigid body kinematics, but still you can say it's related to that. Okay, I'll take up in the next video. I'll take up that. Okay, so this I close it here. Fine.